Hi, this will be supplementary physics lesson covering your homework lesson for section 18A in your textbooks. So right now, for the remainder of the year in physics, we're going to delve into electricity, magnetism. Then you'll see how those two concepts are related. In electromagnetism, we're going to study some electrical circuits, and that's going to be pretty much what we're going to be doing the rest of the year in physics. Excuse me. So you've already watched you've already read one chapter kind of introducing the subject of electricity. We'll be watching some more of those crash course videos through the course of this, and we're going to be working on chapter 18 in the textbooks today, and next week we're going to do a lab 4.1 electrostatic charges in your lab book related to chapter 18. It's a real simple lab, so if you want to start thumbing through that, you can do that. So real quick, let's just take a step back of kind of where we've gone in physics and where we're going here this last couple weeks. Okay, so really the universe in a physics sense, it boils down to two things: matter and energy. And I'm sorry about the glare on our screen here. I've gone to a room in school here and drawn the shades, and that's the best I can do. So I'll be reading each of those points under each to help you along if you want to take notes. So for matter, okay, if you remember back to our study of elementary particles, okay, that's what we have up here. Okay, we said there's four characteristics of elementary particles. Now we're saying those are the particles that are smaller than the atomic level. Okay, so these are the things that protons and neutrons are made of. Okay, some people believe electron itself is an elementary particle. Some believe that even the electron is made up of smaller particles. Okay, but as far as they know now, okay, those subatomic particles, elementary particles we call them, have four defining characteristics. One, they have mass. Okay, they make stuff. They're made of matter. Okay, physical entity. They have a motion. In the elementary sense, subatomic particles, they call that the spin. Okay, but that particular particle, even though it's continuously in motion. Okay, they have a charge. Okay, and that's what we're going to be getting into in this chapter. Okay, an electric charge, and they have a magnetic moment or a magnetic field associated with them. Okay, and so because of this, talking about the bottom two here specifically, okay, electricity and magnetism have very much to do with the state of matter itself. Now we often think of matter just that it has mass, okay, but down at the smallest level, okay, matter, elementary particles that matter is made of, have these four characteristics, and mass is only one of them. Okay, they have motion. They already have energy associated with them. We know from our definition and study of work, okay, any motion caused by a force, and motion must be caused by a force, or a change in motion over a distance creates work. So we have motion, we have energy, work being done at the subatomic elementary particle level, okay? And we also have charge and magnetism built into the fabric of matter itself, okay? Now let's look over here on the energy side. Now, we focus mostly on mechanical energy so far in physics, the energy of things in motion, an object in motion, kinetic energy, or the potential to have kinetic energy if released, okay? And so the universe, the other half of the equation, energy, okay, and as I said, the energy, the ability to do work, okay? To do work, our equation for work was force times the distance. We must have a force, okay, to change the state of motion, and it must be performed over a distance. And we know from our earlier study of force, there are 4 fundamental forces in the universe. I have them here listed from strongest to weakest. The first one, the strong nuclear force, okay, we said that that has a magnitude of 1, okay, we'll compare the rest of them to the strong nuclear force. That's the stuff that holds these elementary particles, the atomic particles, together, okay? We have an electromagnetic force, okay? This is the combination of that electric charge and magnetism inherent in matter itself, okay? This creates a force. And as we notice here, second on the list, it's a rather strong force, only 3 decimal places removed from the strong nuclear force, okay? The next one is the weak nuclear force. That one's a bit harder to explain. We're not even going to touch that one here in our physics. That would be a hard one, area of study even in college physics, okay? But this has to do with how nuclear, certain nuclear pieces of matter decay and they release particles that they once held together in them, okay? That's third on the list. And then the weakest of the forces, and this is the one we've studied the most here in physics, gravity, okay? It's 45 decimal places removed from strength of the nuclear force, okay? 42 decimal places weaker than the electromagnetic force. Okay, so as we get into our study of electricity, electric charge, and magnetism, we realize these are pretty strong forces when compared to gravity. And we think of gravity as a pretty strong force. Keeps our feet firmly on the ground, okay? Keeps us from spinning off into space, okay? It keeps large objects in place. And we like gravity. We think of it as a very strong force. If we try to pick up a heavy object, we feel how strong that force is. And yet compared to the other fundamental forces in the universe, it's rather weak, okay? And then I have these arrows up here. And so the debate rages in physics, okay? Is matter and energy interchangeable? That's what that question mark is. Okay, and we have conservation laws in physics, okay? The conservation of matter and energy. There's only so much matter in the universe. There's only so much energy in the universe, okay? New matter cannot be created, okay? That's man's laws, okay? The laws of physics. Of course, God can create matter out of nothing. That is our belief, okay? But as far as it goes now, the creation now, no new matter can be created and matter cannot be destroyed. Energy cannot be created and energy cannot be destroyed. We've discovered that when we're doing work with energy, okay, we're converting energy from one form to the other, and that is the case all the time in our world. And in fact, your reading said with electricity, one of the great benefits of electricity is that its ability to transfer electrical energy, or more appropriately, electromagnetic energy, long distances, okay, from power plants to here in Coleman, and then we can convert that into another form of energy, maybe mechanical energy, turning a motor to turn a fan to keep your house cool, or heat energy, okay? Heating a room or heating elements in your toaster to make your toast brown, okay? And so physics has to deal with that all the time, conversion of energy from one form to the other. And every time we convert, though, There's nothing that is totally 100% efficient. We lose energy in forms of light, heat, sound, and in our exploration of electromagnetism, we're going to show how that happens, okay, and how that energy is lost, how it's sent out into the universe, okay. And so the debate rages. Are they interchangeable? We know we have fixed quantities, okay. If I increase this one, will that one decrease? Can we do that? Okay, there's much debate about that. We know under certain conditions that can be the case. Einstein's famous equation, E equals mc squared. Energy can be released when matter is converted into energy under certain circumstances, okay? But can that happen wholesale? Can that happen in any instance? Physicists are up in the air. We really don't know a whole lot about that equation, that answer to that right now, okay? So that's just where we're going. So we're gonna park here. Why are we gonna focus so much on electricity and magnetism? Well, we see two of the four characteristics inherent to matter have to do with electricity, electric charge, and magnetism, okay? The second strongest fundamental force in the universe is the electromagnetic force. And of course, our modern society is built on the fact of electrical energy. Easily derived, easily transported, fairly cheap way to distribute power and convert it to many other forms of energy that we need to do things in our society. So electricity, electric charge, magnetism is one of the concepts up there in physics, very important in our understanding of the universe, and for modern day people like ourselves, very important to our society. Okay, so it's important that we kind of understand what's going on. So that's just a quick introduction. I just wanted to go over two quick helps on your homework for section 18A, that review questions. Number 6, they didn't really go over this well in the book. What are the electrics that are used in school labs are made of what category of materials? So I'm just going to show you. We have a friction rod set here, and this is the kit that I'm going to be giving you to complete your lab 4-1, and I'll just show you real quick. What do we have in it? Okay, we have a glass rod, okay? We have a plastic rod. It's clear as well, has a point on it, but it's not glass, it's plastic, okay? And then we have a hard rubber rod, okay? And then in that set, they give you a piece of fur. We have a piece of flannel that we're going to use in place of wool. And we have, well, they called this silk. To me, it feels and looks like polyester, but it's going to do the same thing, a piece of silk to do that. So we're going to repeat a lot of those same experiments they did early on in the research, the observation, the study of electric charge when we do that lab. And you're going to use the same materials that these scientists did back over 100 years ago, developing the theory of electric charge, electricity, and magnetism, okay? So that's what's in our kit I'm going to give you. You have to determine then what category of electrical material they are. Number 6, list the variables that Millikan used to control his famous oil drop experiment. This one will just take a little bit of thought, okay? So just think, you know, what in the labs that we've done so far, and they're rather very simple, rudimentary labs as far as physics goes, what are the problems that you have had coming up with accurate results and results that jive with accepted values of stuff? Our percentage of errors at times have been pretty substantial, and that's because we're not using, okay, really expensive fine-tuned equipment. We're using about as simple a lab equipment as we can. So just some ideas to shoot at your way. you know, think about what he had to do to determine the fundamental charge of an electron. And by the way, I went through this chapter, I was surprised it didn't even indicate what the fundamental charge of the electron is. So what I want you to do is put number 8 on your review questions there and answer this. What is the fundamental charge? Okay, it's going to be recorded in units of the Coulomb, okay, and I'll give you a hint, it'll be one of your appendices in the back of the book. You can find that value. So number 8 on that question set, 18A, tell me what the fundamental charge of an electron is from looking it up in the back. Okay, back to number 7. So my points come up if we were doing his experiment today, would be 1, okay, controlling how big he was injecting oil droplets and letting them fall through the air. Okay, how do you determine and regulate the size of oil droplets so you get the right speed? He wanted them to come to a terminal velocity within his device. He wanted them to start accelerating due to gravity, but the air inside the chamber they would reach a terminal velocity, and he was measuring that velocity. So how big a oil droplet, and how do you get it to be consistent? You know, that was one of the variables that would be very tricky. Okay, he was bombarding these oil droplets with X-rays to impart electric charge to them. How he knew how to do that, I don't know exactly. It'd be kind of interesting to see. I was thinking it'd be interesting to duplicate this experiment until we got to the X-ray machine. I don't know if that would be such a good idea then. But, you know, okay, how much X-ray, how much radiation do you bombard those oil droplets with? Okay, and how much juice do you have to provide to that? What kind of device do you need? How do you tune it to the right value to get the right charge on the particles, on the oil droplets, I should say. Okay, he was calculating the terminal velocity of those, those oil droplets, okay, with a microscope, okay, and we've measured distances with rulers and stopwatches and trying to time things. And how do you determine a velocity experimentally in that small of area? And remember, he's dealing with very, very, very small numbers. Okay, so he needs to be really accurate. Okay, how do you determine the velocity of an oil droplet in a rather short time period with any accuracy? Then he applied an electric field, and we'll get into that later, how what the deal with electric fields in our next chapter. But he applied an electric field to suspend some of those particles. So he's using electric charge to create a force opposing the force of gravity. Gravity is pushing the droplets down. The electric force is going to push them up. If he can balance those, okay, he can get the oil droplets to suspend in the air, and that's what he did. And how do you tweak that electric field so finely that you can get them oil droplets to suspend in the air? Okay, and then the other one is, you know, he's spraying things in to the chamber. He has particles falling, and how do you keep the air, because he's calculating the air resistance to achieve the terminal velocity of these oil droplets. Okay, how do you keep the air inside the chamber still enough to make sure you're not getting influence from a lot of different things? You know, I'm thinking especially the spraying of the atomized oil droplets into the can itself. So those are just factors I just thought, man, how would you take those into account? How would you do those accurately? If you can think of something else in that experiment, you're free to write that down. You're free to take those ideas for answering the question. So just think about it, and I was just wanted you to think about it in the sense of the difficulty we've had with rather real simple labs coming up with accurate results, okay? This was a rather complicated lab involving really small quantities and measurements, and yet he came up with pretty accurate results, okay? So that's all I had for this lesson today. Sorry this video is so long. Just kind of wanted to explain where we're going from here, why we're focusing in on electricity and magnetism, how it fits into the picture of the universe, and then to help you with a couple questions with your homework. So that's it for now. We'll be talking to you later. Bye.